Hello, dear students in grade 8. I hope you are all fine. In this video, I'm going to share with you what we have covered during the previous week in class, your friends and me. When studying mathematics last week, we were talking about a new lesson, which is the congruent right triangles. Last year, we talked about a lesson about congruent triangles, but the lesson of last year was only applied in all kinds of triangles, in in an isosceles, in an equilateral, in a scalene, in a right, whatever. So last year, the three cases that we studied together were proving two congruent right triangles by side, 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 or SSS, side angle side, or SAS, angle side angle, or ASA. But during this year in grade 8, we are only talking about cases that can be applied in right triangles, triangles having a right angle in them. In right triangles, we have two cases of congruent triangles. The first one is called the hypotenuse side, or the HS, or the hypotenuse leg, the HL. This is the same case because side is also a leg in a triangle, in a right triangle. And the second case is the hypotenuse angle, or the HA. But before I start, let me move quickly to what I did with your friends. I reminded them, when do we say about two triangles they are congruent? This means that these two triangles are equal to each other's. You know that in a triangle we have three sides and we have three angles. So if you have triangle ABC and triangle EDF, as you can see from the marks, side AB is equal to side ED, side DF is equal to side AC, side BC is equal to side EF. And the three angles in the first triangle are equal to the three angles in the second triangle. This means that if I put these two triangles above each others, they will look like as if they are one triangle only. The cases that we studied last year, I solved some exercises for you. The first case to remind you about is the side, 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 which is the SSS, and how we can prove two triangles congruent by side, side, side. Then the second case was the side angle side, or the SAS, and we have three different figures of about this case. Now we will be moving to talk about right triangles. You know that in a right triangle, one of the three angles of the triangles, its measure will be 90 degrees, or it will be a right angle. So in this triangle, this is the right angle. Always, if you look opposite to the right angle, you will see a side. This side is called the hypotenuse. In a right triangle, there are two legs or other two sides. The vertical side, or the vertical leg, is called the height, and the horizontal leg is called the base. The first case in congruent of right triangles, two triangles are congruent by hypotenuse side or hypotenuse angle. We call it HS or HL. Mainly, we use it HS, which is the hypotenuse side. How do we apply this case? If we look at two right triangles and we can find that the hypotenuse in the first triangle is equal to the hypotenuse in the second triangle, then we find a side in the first triangle is equal to the side in the second triangle, then these two triangles will be congruent by HS. This is how we apply it. Always we should say in which triangles we are proving to be congruent. Then we say what we have in these two triangles according to the given marks. After that, we say as a conclusion that the two triangles are congruent by HS. If you look at the second figure, we have two triangles which are ABD and ADC. As you can see that these two triangles are right. The first triangle is right at D, and the second triangle is also right at ADC. In the first triangle, the hypotenuse is AB. In the second triangle, the hypotenuse is AC. So as you can see, the two hypotenuse has the same marks. Then AB is equal to AC. These are equal hypotenuse. Let's look to another side. We can see that side AD is a common side. It's found in the first triangle and in the second triangle. Then these two triangles will be congruent by HS, and this is how we write the proof. Now, the second case of congruency in right triangle is called the hypotenuse angle, or the HA. So two triangles are congruent by hypotenuse angle, or HA, if the hypotenuse in the first triangle is equal to the hypotenuse in the second triangle, and an angle, acute angle in the first triangle is equal to an acute angle in the second triangle. As you can see, in triangle OPQ, it's right at P. In triangle KIJ is right at I. So in the first triangle, the hypotenuse is OQ, which is opposite to the right angle. In the second triangle, the hypotenuse is JK, which is opposite to the right angle. From the marks, you can see that OQ is equal to KJ, then the two hypotenuse are equal. And we can see that angle OQP is equal to angle KJI according to the blue marks given. Then these two triangles will be congruent by HA. Also, in the second figure, you can see two right triangles, QRS and STU. These two triangles, the first one is right at R, so the hypotenuse is QS. The second triangle is right at T, so the hypotenuse is SU. From the marks, you can see that QS is equal to SU, and the right angle QSR is equal to TSU. These are vertically opposite angles. They are equal. So this is how we prove it. Then the two triangles are congruent by HA. This was the lesson that we started last week, and I'm not done yet with the exercises. We are still solving exercises in class, and daily I'm sending you on WhatsApp all the exercises we are solving in class for you to practice also at home. Please, if you have any question, don't hesitate to contact me. Thank you.